Let x1, x2, x3 be a random sample from a discrete distribution with probability function here. Find the MGF of y equals x1, x2, x3. So if we take a sample from a distribution, and then each of these sample variables has the same distribution as this given distribution. So, and they all have this discrete distribution where each of the xi's could be either 0 or 1 to give a meaningful probability. Otherwise, the probability is 0. So the two cases to consider are case 1 when x1, x2, and x3 are all 1. So in this case, y will be 1 because y is the product of x1, x2, x3. And then we are saying x1 is equal to 1 and x2 is equal to 1 and x3 is equal to 1. And so the probability of each of them being 1 is 2/3. And the result and would mean multiplication. So 2/3 times 2/3 times 2/3. So that's 8/27. And then when all three are 1, then y is 1. So basically y will be 1 with probability 8/27. So that's case 1. Case 2 is then when at least one of the xi's is not 1. So we agree that logically these are the only two cases possible, that either all the xi's are 1 or at least one of them is not 1. So when at least one of them is not 1, then that means that at least one of them is either 0 over here or it's something here. Otherwise, it's neither 0 nor 1. So this case, when it's neither 0 nor 1, that gives a probability of 0. So that doesn't contribute eventually in the expected value that we need. Remember, expected value in this case will be a sum, since it's a discrete variable, and each sum has a corresponding probability multiplied with it. So if the probability is 0, then that doesn't contribute to the sum. So therefore, in order to have a non-zero probability, the xi's have to be either 0 or 1. So since we are at the case where at least one of them is not 1, so for non-zero probability, it means that at least one of them is 0, because if all three are non-zero, then we are over here, and the probability of this situation is 0. Yeah, because we've already taken the case all ones out of the way. And so now we're at a case where at least one of them is not 1. Let's say x1 is not 1. So then x1 will either be 0 or it would be something else. So something else doesn't interest us because that's probability 0. So with the only situation in this case from which we will get a non-zero probability is when at least one of the xi's are 0. But even if one of the xi is 0, then the product is 0, and that means y is 0. So it means the only probability you will get in this situation is when y is 0. And since these are the only two cases, in case 1 probability is 8/27, so case 2 probability will be the complement of that, that'd be 19/27. And therefore the distribution of y will look like this: 8/27, y equals 1. That was case 1. And in case 2, we concluded that for having non-zero probability, at least one of them has to be 0, and therefore at least one of them 0 results in the product being 0, which means y is 0. So y could be 0 with probability 19 by 27 or 1 with probability 8 by 27. So now that we have the PDF of the PMF of y, we are ready to find the MGF. Remember, MGF is the expected value of e power ty, and since this is a discrete variable, so it'd be the summation over y of e power ty times gy. That's the definition of expected value. And then the only two values of y which are contributing are 0 and 1. So when y is 1, so you get e t times 1, g of 1, and then when y is 0, you get e t of 0, g of 0. So g of 1 is 8 by 27, g of 0 is 19 by 27, e to the t times 0 is just e to the 0, which is 1. And this simplifies to choice 19 over 27 plus 8 over 27 et a.